we go to manually add the students. And oh, well, I cannot do it just now because I have to add a student account first. So I can do it later. However, this is still a useful tool. Okay, it is still a useful tool even though you cannot turn in the code, that the compiler generates.
Have you ever used that method in order, like if you were stuck on something in your assembly code to kind of get an idea how the
Yes.
compiler would do?
Yep. The EBX problem, we discovered that problem because of disassembling what the compiler generates, and then we realized, hey, the compiler is trying to use EBX and it's not saving and restoring it on the caller side. So that means if your program is using EBX and trash it, then the compiler will go like, oh, EBX has changed, and bad things will happen. So it is a useful tool. It's a very, very useful professional tool, and that's why I do want to introduce it at the end of the class, because it is a very useful tool to take a look at what the compiler generates as the output of a program. Okay, so are we done with pride? We won't have enough time to finish the other two sins, but we'll try. Okay, do you guys want to deal with sloth, or do you want to deal with greed?
Greed.
Greed? Okay. Okay. There's no good lust, so I don't want it. With greed, you can kind of argue capitalism is good greed, so it's. Okay, so we say tar xzbf bad greed. And go to greed, touch all, make clean. Okay, so this time, let's look at the description here. This one is even more interesting because there's more restriction. And this one actually takes longer to do too. You guys picked the difficult one out of the two. Okay, so in this case, you have to use a /main, a whole bunch of numbers, not just one, but a whole bunch of numbers. The assembly version of print list function is implemented incorrectly, fix blah, blah, blah. In this case, you may only fill in the missing instructions. In other words, I have holes in the sequence of instructions, and all you can do is to fill in the instructions that are missing.
So you can't modify existing lines, you have to add new lines.
Yes, you can only add new instructions, and they can only be single instructions where it is supposed to go. Okay, so we'll take a look. Okay, so the next thing we want to do, as usual, is to take a look at the program. We want to take a look at main.c, which has the C implementation of the program. We have add node here. Add node is not what you have to debug. What you have to debug is print list. Okay, _C is this version here. It is not even recursive. This one is not recursive. Okay, so what we want to do is to say, well, we'll just go ahead and see what it does, okay? And if we want to see what it does, one thing to do is to change the make file so it does not include the assembly version of that. So make, and then run main, and you can just give it a bunch of numbers, 2, 5, 6, 10, 0, or whatever. It will just print those numbers in a reverse order, okay? Are we okay so far with what print list is supposed to do?
Yeah.
Okay, so now we have to compare the C code with the assembly code and basically try to figure out, what the missing instructions are supposed to be. So here we go to vm.main, split the screen so we can look at both the C code and the assembly code. Fortunately, the subroutine is small enough to fit, even within like 10 lines or so. And then we go to print list.uppercase S, and then we just start from the beginning and figure out whether there are problems or not. In this case, I'm guaranteeing in this case that there are no problems with the instructions that are in the program. Okay, so your only task is to find out what the missing ones are supposed to be. So we have OEBB equals to 0. Typical return address is OEBB plus 4. List is return address plus 4, all defined correctly. Push EBP, move ESP to EBP, go to the end of the subroutine, and then we have the reverse. Okay, so perfectly done, no problem with that. and we just continue. Now with this type of program, it really helps to comment each line, and so you can keep track of what the registers are doing, throughout the code. Okay. So this part I don't think really requires any commenting because it is a very typical entry point code for a subroutine. Okay. So we'll just say this is the beginning of the while loop, not really important. Compare list to 0, which is null. Okay. I hope everybody understands that null is actually just 0. And here we are jumping to the end. If list equals to null, exit the loop, which is exactly what the C version is doing. Okay. So everything is good so far, and as I said, the instructions that are in it are correct already, so you don't have to suspect those instructions being wrong. You just have to know what they're doing so that the missing instructions, you understand what is missing, in the missing instructions. Okay, so we have, then it starts to get a little bit more interesting. So we say EAX is a copy of EBP. Does that make sense? Because all we are doing is copying EBP to EAX. So it's an exact copy of EBP at this point. What would this do if I add $list to EAX?
What is list again?
List is the displacement to the parameter called list. How about EAX is the address of parameter list? Is that correct?
Yes.
Okay. And then we push that on the stack. Okay. Push the address of parameter list on the stack. Okay. So now we have two missing instructions, and I do tell you what the missing instructions are supposed to do. So we have one missing instruction here to make EAX a pointer to a struct list node. How do we go from where we have here to where we want to go? What is EAX right now? EAX is, pushing EAX on the stack does not change what it is, right?
Right.
So what EAX is, it is the address of a param list. What is the parameter list?
It's a pointer to.
It's a pointer to list node. Okay, so how do we use one single instruction and turn the address of a pointer? Dereference, exactly. So since the result is supposed to be in EAX2, so we dereference EAX and put the result back into EAX. Sorry?
Is it first member of the struct node? Yeah.
It will be the beginning of the entire structure, yes. Okay, so the next instruction, the next missing instruction is to make EAX point to the value member of a structure. How do we do that? EAX currently is a pointer to a struct list node, which means EAX right now has the address of the first byte of a structure.
We add the member, the offset of the member to EAX.
Very good. So in this case, it is called list node underscore value. Okay. You can look into the inc file. The inc file has all of this stuff defined to EAX. Okay. So this is what you need to do with this type of question, is to track exactly which register is doing what in the program. So when I give you something like this, missing instruction, and make a particular register